and today we would like to present you guys about electric circuits. Electric circuit that contain only one energy storage element, it will be called like first order differential equation. There is two types of first order circuits, RC circuit and RL circuit. Followed by a second order circuit is characterized by a second order DE.
And it consists of resistors and equivalent of two energy storage elements. Example of second order circuits is series RLC, parallel RLC, RI and also RC. Okay, here's some formula that we use for our examples. And this is for first order formula. L di dt plus Ri equal to Et. And for the second order, L d square I dt square plus R di dt plus 1 over C I equal to equation of Et. Okay, E stands for electromotive force, R represents for resistor, L for inductor, and C for capacitor, I for current, and T for time.
Alright, now we're going to solve the problem. So, given that if a battery supply constant voltage of 36 volt and if inductance is 2 henries and resistance is 8 ohm, given that the initial condition I0 is equal to 0, find IT and current after 0.1 second. So this is the series circuit, and this represents the model of voltage, L for inductance, R for resistance.
Okay, for this example, we have the RL circuit. So first, we list all the information that we get from the question. Okay, here is the voltage, which is 36 voltage. The resistance is 8 ohm and the inductor is 2 henry. Firstly, we will write the equation in this form, and for this problem we have the first order linear equation. After we rewrite the equation, we substitute the information that we get from the question to the equation. So from here we get in the form of linear equation. So we solve the equation by using the linear equation. Here we get the mu equal to exponent integrate pt dt and equal to E for t. Now we find the integrating factor. So IT is equal to 1 over mu times with integrate mu times qt dt plus c. Next, we substitute the mu, which is exponent 4t, and time with integrate mu is exponent 40 times 18, which is qt, dt and plus c. Next, we solve it, and then we get is it equal to 9 over 2 plus c exponent negative 40.
Alright, now given initial condition where we substitute 0 is equal to 0. Alright, now from the equation that we got before, we substitute t with equal to 0 in order to solve for the value for c. And value for c we get negative 9 over 2. So this is the equation that models the current. And the question asks us to find the current after 0.1 second. So we're going to substitute t with 0.1 inside the model. And we will get the current after 0.1 second is 1.48 ampere.
Okay, for the application of RLC circuit, we are going to solve this question. Okay, this question here say that an RLC circuit has an EMF of 5 volt, a resistance of 50 ohm of 1 henry, and the capacitor of 0.002. Given I0 is equal to 0. Okay, now we are going to find the current in the circuit. This is the diagram to illustrate this question. Now we are going to solve it. Alright, she will explain first how to solve this problem.
Okay, thank you. So
So as we know from the question, our R is 50 ohm and our L is 1, our ET is 5 and our C is 0.002. Okay, as we know this is the equation and we just plug in into this equation. So we just going to solve it with our characteristic equation, which is R square plus 50R plus 500 equal to 0 because our E prime T is 0 because our ET is 5. Then we solve it using case number 3 in characteristic of equation, and we got negative 25 plus minus 5 in square root 5. So the equation that we get is IT equal to E negative 25t C1 sine 5 square root 5t plus C2 cos 5 square root 5t. So Arifah will continue. Okay, from the question, given that I0 is equal to 0, it means that when T0, I is 0. When the time is 0, the current is 0. So we just plug in this value into the equation we obtained earlier. So when we plug in and to find the constant value, and from here C1 is 0, and we got the value for C2 is 0. So the current IT is equal to E negative 25t C1 sine 5 square root 5t. That's all. Thank you.